What's important to remember, though, is that those polyatomic ions on that list there, they behave just the same way any other ion would. Okay? So even though acetate is this whole big group of ions, it's going to behave exactly the same as any 1- ion would. Okay? Which means that we can't have just a jar full of acetate ions. Okay? We never have any individual ions just by itself. It would have to be paired with what? What would any kind of negative ion have to be paired with? It'd have to be paired with some kind of positive ion, okay, in whatever ratio is necessary to make it neutral. Okay? So we do not have jars of acetate. We have jars of sodium acetate. We have jars of lithium acetate and potassium acetate, all kinds of other things, calcium, right? Whatever plus charge you can make a compound out of, but you need to have opposite charges, and they need to be in the correct ratio to be neutral. Okay? So none of that has changed. The only thing that's changed here is that what we once called just an individual atom is now a group of atoms. Okay? So when we look at CuSO4, I think the first important thing that we realize about that is what ratio of actual ions are in that substance. Okay? And if you just had something like this one, Cu2S, that's simple. Right? The ratio is just 2 to 1. Right? Because I got 2 coppers for every 1 S. Okay? That's simple. But now when we've got something with a polyatomic ion, like SO4, when you see something like SO4, what you need to realize is that SO4 is a group. Okay? It's an S with 4 O's stuck to it that actually behaves as a unit. So you may think of this as, you may think that this would be like a 1-to-4 ratio, but it's not. Okay? What is the actual ratio of ions in this compound? Well, definitely 1 copper. What if I did this? SO4, right? That's an S with 4 O's stuck to it, but they're stuck together. Those O's aren't going anywhere. That's not changing. Okay? I've got a copper ion, right? That's a Cu. And then I've got an SO4 group, okay? Which they're just plastered together. So the actual ratio would just be 1 copper to what? 1 to 1. See if you can get what I'm trying to, I'm not explaining it very well, but we all get there's 1 copper in that formula, obviously, right? But because SO4 is a polyatomic ion, it was one of the ones on our list, okay? It's sulfate, right? SO4 is a group. Okay? Those atoms are stuck together. We count that as 1 ion. Okay? That's the critically important part here. Does that make sense? Okay. So, what we need to do then, anytime that we've got a formula that we need to ultimately name, right? These are all formulas. Let's write the ion pair. Okay. We're going to have a copper ion, and it's variable, so we don't know its charge just yet. Okay. Our other ion is SO4, and we do know its charge because it's right on the list. What is SO4's charge? Yeah, SO4 is 2 minus. Okay? So there's something new right now. Okay? Before, we never wrote those lower numbers over in the ion pair, okay? Because we were only dealing with ions that were made up of single atoms. Okay? We may have had multiple numbers of them over in the formula, but there was this that had some plus charge, and there's this atom that had some minus charge. The difference now is that SO4 is considered a group. That's what polyatomic ions are. So SO4 is the anion right here that has a 2 minus charge. Okay? And then because we said it's a 1-to-1 ratio, 1 copper for every one of these SO4 groups, 1-to-1 ratios are easy for charges, because what would the charge on copper just have to be in this one? Yeah, it would just have to be 2 plus. Okay? So that's what we will use to name this. Okay? The name of any ionic compound is the name of the positive ion and the name of the negative ion. Okay? So copper, then what? Well, the negative ion, I heard somebody say sulfate. The negative ion is definitely sulfate. But I've forgotten something here. Why do we need that? Why do we need the Roman numeral? What does that Roman numeral stand for? Just like always? It stands for the plus charge. And I'm going to draw this arrow right there. We need that because copper is what kind of ion? What kind of charge? Copper is a variable charge ion. We've figured out it's a 2 plus charge because we have one of those coppers for every one of those sulfates in the formula. Okay? So we figured out that charge, but then the name, we have to say copper 2 because it's variable charge. Otherwise, we wouldn't know what charge we're dealing with. Okay? The name has to say what the plus charge is. Okay? Let's try this one right here. What ratio is this one? 1 to 3? It's still a 1-to-1. How come that's not a 1 to 3 ratio? Because what is SO3? SO3 is a group. It's a polyatomic ion. It's a single unit. Sometimes it helps to make that little bracket under there. Yeah, go ahead. Okay. Look at the last page. Yeah, because here's what sulfide is. Sulfide is an individual S with a 2 minus charge. Okay. Sulfate is a grouping of S with 4 O's. Okay. I should bring my model kits out. Okay. But literally what it looks like, there's an S, there's 4 O's stuck to it. Okay. And it's stuck together. Here, I'll draw it. S.
So it's not sulfide because it has oxygens on it.
Yep. Okay. Literally looks like that. Okay. If it was sulfide, there would be no O's in there. Okay. See SO4. Okay. That's what sulfate looks like. It's an S with 4 O's stuck to it, and they're stuck together, and those O's don't come off. Okay? Sulfide, anything with "ide" is just something straight from the periodic table. Okay? Good question. Thank you. All right? But yeah, if that was just CuS, that would be a sulfide. Okay? But now we got SO4, that's that group. It's an S with 4 O's stuck to it. Okay? So here we had CuSO3, but still a 1-to-1 ratio because SO3 is another one of those groups that we've talked about. Okay? So again, ion pair, copper, don't know its charge yet. SO3, however, we do know its charge. It'll be 2 minus again. Right? It'll have the same charge as SO4, okay? Just 1 fewer oxygen. Okay? So then what charge will this copper be? 2 plus again, because the ratio is 1-to-1. So then the only thing different about this one, still copper 2, right? but this one's going to be copper 2 sulfite. Okay? One letter makes a difference, right? Ate and ite and ide. Okay? They're totally different compounds. Okay? Sulfate, sulfite. Okay? That's the difference. Okay? All right. Can you tell me what the ratio is in this one? It is 2 to 1. Okay? Because we got 2 coppers, but then SO4 is just one group of them. Okay? So it's going to be SO4. I want you to see if you can predict this charge right here. Write the name. Then see if you can do it with these other ones, okay, down to Cu2S. Write the ratio. Write the ion pair. Write the name. We'll see how you do. Yep. Yep. Still needs a Roman numeral, though. Yeah. All of these will have a Roman numeral in their name. Okay, so I like how you drew that out, but as a group, that's not neutral. What would those have to be for as a group that to be neutral?
Well, they don't have to be pluses.
So there have to be some kind of pluses, but if you have 2 plus and 2 plus, that's 4 plus. That doesn't balance with the 2 minus.
Okay.
So what do you think?
They would just be 1 plus.
Yeah, it'd be 1 plus, and that's what goes in your Roman numeral.
Okay.
Okay. So I'll give you a hint. What's in that first blank box there is not a 4. I saw some 4s. That's a common mistake, but that's not right. Yeah, close. Metals are always pluses. So your number is right, but yeah, there you go. Yep. It's always some kind of plus sign, then some kind of minus sign. Okay. Not quite. 2 plus would work if we had a 1-to-1 ratio, like we did up there. Whatever you put in that box, we need 2 of them in the formula, right? Because the formula is Cu2. So whatever you put in that box, we need to then have 2 of those in order to balance sulfate. So I can get how you might want to be writing 4 there or something like that, but the deal is, whatever I have in this box here, I am going to then have 2 of, right? Because I have a 2-to-1 ratio. I have 2 of these plus signs for every 1 of those. So what has to go in the box then? 2 plus? 1 plus. If we had 2 plus, right? 2 plus, and then I had 2 of them, that would make 4 plus total. And that doesn't balance with this sulfate. Okay? It has to be 1 plus because, look, copper 1 plus, I have 2 of them in the formula, which will balance with the sulfate. So a couple of you drew stuff. You could do something like that. If I drew it out like that, could you see how if I had 2 plus in those boxes, we wouldn't have a neutral group? Mm-hmm. Yep. Yep. The 2 to 1 ratios, they're really just as common as 1 to 2 ratios. Okay. So, but yeah, 2 to 1 ratio means we've got 2 of the plus ion. Okay. So, and if you had 4 plus in those boxes, it'd be even worse, because then you'd have 8 plus total, which doesn't at all balance to the 2 minus. Okay? So you need to have single plus in that kind of case. See how that works? To balance with the 2 minus. So it's really whatever charge here, okay, times how many of them are in the ratio. So what's that one called? Copper 1. Sulfate. Good. Good emphasis. Sulfate. Okay. What's the ratio down here? Still 2 to 1. I don't know if it's helpful to make that sort of like a group there. But this is going to look a lot like the one above it, except it's going to be SO3, 2 minus. But what charge is going to be in the box then? Yeah, it's going to be 1 plus again. Oops, I want that red. 1 plus. So the only difference here, copper 1, that's sulfite. Okay. And this last one, here's one like we were doing last time. S alone, okay, S alone. What's S alone called with the 2 minus charge? Sulfide, okay? And what's going to be in the box here? Again. Yeah, I got 2 minus. I've got 1 of them. I'm going to need to have single pluses in that box because I need 2 of them in this formula. Okay? So copper 1 sulfide. Okay? So in those fairly, in these pretty, I don't know, similar examples, we've shown sort of what the subtle differences are, though, in these things. All 5 of these are completely different compounds. Okay? They'll be totally different in about every way you could imagine. They'll have different densities. They'll have different molar masses. Okay? So pretty much everything you could think of is different about those. And their names are different in some cases, in almost all cases, by just 1 letter. Okay? So having a real eye towards detail, the 8 versus, in these first 2, the 8 versus the ite, that's the whole problem right there, 1 letter. Okay? So it's being very careful with those endings, being very observant, okay? Making sure that you're able to understand that. So let's go the opposite direction. Let's start with a name. And remember, whenever you're given a name, you pretty much automatically have the ion pair. Because copper 2 nitrate automatically means that copper has what charge? 2 plus. It's right there. Okay. Now take a look for me. How many O's are in nitrate? NO, NO3 with what charge? Single minus. Okay. It's not just NO3. Okay. NO3 alone would be a compound called nitrogen trioxide. Okay. But if NO3 shows up within a compound, it is a nitrate ion that has a 1 minus charge. Okay. So if those are the ions that are available to us, copper with a 2 plus, nitrate with a 1 minus, what is the ratio of those that we need? 1 to 2 ratio. So the formula would be, I need a 1 to 2 ratio of those ions. Would it be CuNO2? Oh, did I make a mistake? What did I do? I changed nitrate into nitrite. You can't do that. Don't erase it, though. Put a big X through it, because I want you to see that that's a mistake. Okay? NO3 nitrate ions, those are the ions that we have. We can't change that. It's an N with 3 O's stuck to them. Okay? So I got to have NO3. So is it CuNO3? No. That's a 1-to-1 ratio. How do I make a 1-to-2 ratio? We need to put parentheses with a 2 there. Okay? Anytime our ratio is more than 1 on a polyatomic ion, it needs to be put in parentheses so that it's that group that we're doubling or tripling or whatever. Okay? That's very important. Okay? Why don't you write the ions for ammonium and phosphate? Those are both polyatomic ions. It's not always the minus one that's the polyatomic ion. We had a plus polyatomic ion on the list, so you can use that. So write the ion pair, figure out what ratio you need, and write that formula. What is ammonium? Yeah, NH4 single plus. What is phosphate? PO4 3 minus. Okay. We need what ratio then? We need a 3-to-1 ratio. So okay, so how would I use those two ions? How would I write that in a 3-to-1 ratio? NH4 parentheses 3. Then what? Yep, then just PO4. Okay? NH4 parentheses 3 PO4. Okay? Anybody have questions about those two? When do we use parentheses around a polyatomic ion? When you need more than one of that group. Okay? If your ratio tells you 2 or 3 or 4 or anything more than 1, you need parentheses around it and use that. Okay? So give these next three a try, because we're back to formulas. Okay? And the tough part on these ones really is going to be just figuring out what the ratio is. Because those parentheses make a huge difference. Okay? You'll do ratio, you'll do ion pair, and then name. For each of those. All right. Let's see how you do. Those first two look pretty similar except for the parentheses, but those parentheses turned it into a totally different compound in every way. Yeah, for these ones, write the ratio underneath those formulas. That's going to be important. Once you've figured out maybe those first two, see if you got the same Roman numerals that your neighbor did. Careful. This is a 1 to 3. There you go. If you're given a number, here I'll give you a hint. If you're given a number that's outside parentheses, that number is a ratio number. Yep. There you go. 1 to 3 ratio. Yep.
I had 3 to 1, but then you said that.
No, it's 1 to 3. Yep.
And then
Okay.
for the ion pair, what are we supposed to write? Because manganese is positive 7, right?
Nope.
Negative 7?
Manganese is variable charge.
So it could be anything?
Yep, can be anything.
That doesn't make any sense.
So ClO though, what is ClO?
Negative 1.
Yep, ClO is negative 1. It's right here. Yep.
So
Okay.
we have 3 of these. It's going to be 3. So
Yep.
it has to be plus
That has to be plus 3. Yep. Yep. That's not so bad. What ratio are the ions in this first one? What does this formula tell you? 1 manganese, 3 of those. What's the ratio in this one? 1 to 1. Because here, ClO is our group, and we have 3 of them. Here, ClO3 is the group, and we have 1 of them. If you can understand the difference between those two, then you're well on your way. But because we got a 3 outside parentheses, that means 3 of everything inside of there. So 3 of this whole group. Whereas in this one, we've got a chlorine and 3 O's. That's a chlorine atom with 3 O's stuck to it. That's one group. Okay? So again, Mn is variable charge. We know ClO is 1 minus. Right? That's from the list. Because ClO is 1 minus. Look at the ratio here. What charge does this Mn need to have? 1? Yeah, this would be 1 plus if it was a 1 to 1 ratio. Okay? But look, ClO is minus. Right here we've got 3 of them, so this manganese has to be 3 plus. It's going to be manganese 3 plus and 3 of those ClO minus. So this first one is going to be manganese, what? Manganese 3, first of all, then hypochlorite. Okay. This next one is different because over here in the ion pair, I'm going to call that ClO3 1 minus. Okay. Over here in the ion pair, we just write what the atoms are that are in that group and then its charge. So ClO3 will have a 1 minus charge. So what charge will this manganese get? This is a 1 plus because that's a 1 to 1 ratio. We have 1 manganese ion for every 1 of these ClO3 groups. Okay? That one is called what's this one going to be called? Manganese 1. Got to have that Roman numeral still. And that's chlorate. Okay. What about this one? NaClO. What ratio is that? Yeah, it's 1 to 1. How come it's not 1 to 1 to 1? Because ClO is a group. Okay. And but what's different about sodium's charge than those other ones? Sodium is fixed. Sodium is always 1 plus. Sodium 1? No, it's fixed. We don't need a Roman numeral. Sodium is always 1 plus. So it's just sodium. Sodium. I gave you this one because sodium hypochlorite is in the active ingredient in bleach. So if you ever look at the container of bleach, it'll say like 5% NaClO or 5% sodium hypochlorite. Okay? That's why that's there, because it's made out of sodium ions and hypochlorite ions. All right? All right. Back to names. So on names, whenever we name an ionic compound, we are naming the positive ion and the negative ion. So with names, write the ions right underneath the name there. Okay? That'll be helpful. And then see if you can write those formulas for it. See if we can do these. Start comparing with your neighbors once you're getting formulas of these. Ca. Oh, calcium's not 1 plus. Check periodic table. Close. Yep, your charges are right. It's just over in that formula to make that a 2 of the OH group instead of just the H.
Oh, you have to put.
Yep. 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 Okay. How are you doing there? Oh, so calcium and sodium, no Roman numeral to give you the charge. Okay, so you gotta go back here. 2 plus. Yep. 1 plus. Mm-hmm. Yep. Yep. Calcium was 2 plus. Yep. But titanium, we gave you its charge right there. Mm-hmm. Yep. Where will you find the charge of calcium and sodium? You look on the periodic table. Those are fixed charge metals. You probably have a periodic table somewhere with those charges drawn in. Oh. Okay. 2 plus from the periodic table. And then what is hydroxide? OH 1 minus. Okay. So I tend to see that an awful lot for something like calcium hydroxide. It's the right idea, but what's the problem? Yep. And I'm actually going to keep it and put an X through it so you see that. Anytime we need 2 or more of a polyatomic ion, it has to be in parentheses. Okay. People don't usually forget the parentheses if there's already a number that you'd be changing or covering up. But something like OH, you still need those parentheses because that 2 has to apply to that OH group and not just the H. Okay. So don't forget that. Do that pretty common. Sodium is plus bicarbonate. What is bicarbonate? Yep, it's a carbonate with an H added and the charge taken down by 1. So that's easy. It's just plus and minus. So NaHCO3 Anybody know what sodium bicarbonate is also called? Yeah, sodium bicarbonate is baking soda. Do I give you that one? Okay. So titanium is variable charge. So how on earth am I going to figure out the charge that this titanium happens to have in this compound? Where am I going to... What far reaches will I have to go to look up what plus charge titanium has in titanium 6 phosphate? It's silly, but you would be surprised how often when given a Roman numeral like that, when we get into all this switching around and doubling and all that figuring out, when you're given the Roman numeral, it's literally telling you what the plus charge is. It's right there. Okay. What is phosphate? Okay. Ti3 PO4 6. Close. Ti parentheses PO4 2. Okay. Before we go, I want to show you something. Here in D2L, I'm going to go to Content and Links. Okay. I showed you these Quizlets before, right? Maybe a couple of times. If you go in here, there are several of them that will be very useful to you right now. First of all, just the polyatomic ion. So here's one with just the 8s. Here are 8s and 9s. Those are just the ones to memorize, the ones straight from the list. Okay. And then I've actually done some where I've made compounds. Okay. So variable charge ionic compounds that contain polyatomic ions, for instance. Okay. You can quiz yourself on things like that, right? It'll give you a formula and you have to write the name. If you do C term first, it'll give you a name and you have to write the formula. Okay? So it's a little extra little quizzing that you can do. And you can play little games and stuff with that. Some students have found that to be very helpful. Okay? So we'll do the last page, I guess, of chapter 5 next time. We'll do the acids at the start of next time. You won't have any trouble with that, but I will see you all in lab also between now and then. Come and get your exam up here if you haven't yet.